Have you ever wondered how many ways you could shuffle a playlist? Or maybe what the odds are of winning the lottery? Well, today we are pulling back the curtain on counting with permutations and combinations. Let's get into how to count what really counts.
So think about it for a sec. If your bike lock code is 123 and you try to open it with 321, no lock, right? The lock isn't going to open. But a pizza with pepperoni and mushrooms? That's the exact same pizza as one with mushrooms and pepperoni. That one simple difference, honestly, it's the key to everything we're about to talk about.
You know, when it comes to counting all the possible ways something can happen, it pretty much always boils down to one of two scenarios. It's kind of like a tale of two choices that are super easy to get mixed up, but don't worry, we're going to make it all crystal clear.
And here it is, the big secret, laid out plain and simple. Permutation is all about arrangement. Combination is all about selection. That's it. One cares about the sequence you do things in, and the other one just cares about what you have in your hand at the end.
Okay, let's dive into our first concept, permutation. For this one, all you need to remember is one simple phrase. Order is absolutely everything.
So the official textbook definition says that a permutation is the arrangement of items where the order of selection is critical. This is our bike lock example, right? The specific sequence is the only thing that works. Seriously, if you take away just one thing about permutations, let it be this. Just burn this into your brain. With permutations, order matters. That is its one single defining characteristic.
So, let's look at an example. If we take three letters, A, B, and C, and we want to arrange them in pairs, we get 6 totally different outcomes. See how AB and BA are counted as two separate things? That's the permutation rule in action. To a permutation, they are completely different arrangements. And yeah, of course, there's a formula. Don't let it scare you. N is just the total number of things you have to choose from, and R is how many you're actually picking. That exclamation point, that's called the factorial, which is just a fancy way of saying you multiply that number by every whole number below it. We're not going to get lost in the math here, but that formula is the engine that makes all of this work.
Okay, now let's talk about its counterpart, combination. With this one, the rules of the game are completely flipped. Order is totally 100% ignored.
The formal definition tells us that a combination is all about selecting items from a group where the order you pick them in is completely irrelevant. This is our pizza topping scenario all the way.
And here's the other mantra you need to know. For combinations, it's this simple. Order doesn't matter. It's all about the group you end up with, not the journey you took to get there.
So let's go back to our three letters, A, B, and C. If we're just selecting a group of two, well, the group that has A and B is the exact same as the group with B and A, so we only count it once. This shows you perfectly why we end up with just 3 combinations, instead of the 6 permutations we saw earlier.
Now, the formula looks pretty similar, but it's got one crucial addition. See that extra R factorial on the bottom? That's the secret sauce. That little piece is what does all the magic. It divides out all of the duplicates that ordering creates, which gives us that smaller, correct number of combinations.
All right, let's put these two ideas head to head. I think this side-by-side comparison is going to make the definitive difference totally clear.
This slide, right here, boils everything down perfectly. Just look at the meaning. Arrangement versus selection. And the core example really drives it home. With permutations, AB is not the same as BA, but with combinations, they're identical. This is why you should always be on the lookout for keywords. If you see words like arrange or order, you should be thinking permutation. If you see select or choose, you're probably dealing with a combination.
So why does any of this even matter? Well, it's because these concepts aren't just for math class. They are literally everywhere. Let's try to apply this logic to a couple of real-world problems.
Okay, here's a classic situation. You've got 10 people, and you need to form a committee of 5. Now, before you even think about reaching for a formula, you have to ask yourself the single most important question.
So, you ask yourself, does it matter if you pick Sarah first and then John versus picking John and then Sarah? No, of course not. They're both on the committee either way. The order is totally irrelevant, which immediately tells us, ding, 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 we're dealing with a combination.
And when you plug the numbers into our combination formula, 10 choose 5, you find out that there are 252 different possible committees you could form. That's way more than you might guess, right?
All right, on to our next problem. You have 5 different books, and you want to place them on a shelf. How many different arrangements are possible?
This time, does the order matter? Oh, absolutely.
Having a history book next to a science book is a totally different physical arrangement than having it next to a novel. The sequence is the whole point, which tells us right away that this is a permutation problem.
And using the permutation formula here, arranging all 5 books from a set of 5, we find out there are 120 different ways to line them up on that shelf.
You know, in the end, it all just comes down to this one single powerful idea. This is the big takeaway. If you can just answer one simple question, does order matter? You can solve any of these problems.
So there you have it. The secret isn't really about complicated math, is it? It's about asking one simple question. Now that you have the key, just think about all the problems you can solve, all the possibilities you can finally count. So, what will you unlock?